Hello and welcome to the second episode of this tutorial series on GARCH models. Today I will show you how to program a GARCH model which uses a t-distribution for the errors. In the previous episode we programmed a normal distribution for the errors, but as you may know, financial asset returns exhibit leptokurtosis, which is a kurtosis value higher than 3, which is the kurtosis value of the normal distribution. This is also known as fat tails. Therefore, I will show you how to program the t-distribution. This is not much effort, since we made our code easily expandable for other distributions. The t-distribution has an extra parameter, the degrees of freedom parameter. So we need an initial value for this and the bounds for this parameter. Therefore, we make two functions. The dist initial function, which has the distribution as argument, and the dist bounds function, which has the distribution as argument. These two functions will return an array with the initial value for the degrees of freedom parameter and an array with the bounds of the degrees of freedom parameter. So now create the function at the top. A function, of course. If the distribution is equal to the normal distribution, we of course return an empty array, since the normal distribution doesn't have any additional parameters. If the distribution is equal to the t-distribution, which we are programming now, we return an array with a value of 6. 6 will work fine as an initial parameter for the degree of freedom. We'll also program the function for the bounds. Same story for the normal distribution, there's no additional parameter, so just return an empty array. For the t-distribution, the degrees of freedom parameter must be bigger than 2. So we return an array with as minimum value 2.1. As maximum value you could say infinity, but in practice 30 or so works fine. You'll never see 30 in practice, I think. So now we have an initial value for our degrees of freedom parameter and a bound, and the bounds for this variable. Now we only have to program the log PDF for the t-distribution. For this we need to import the log gamma function from SciPy. Now in our general log PDF function we have to say if the distribution is equal to the t-distribution, return the log PDF of the t-distribution. With the same arguments as that of the normal PDF. Now, the log PDF of the t-distribution is a bit more complicated than the one of the normal distribution, so I would advise you to just copy my code because it works. And we need to return this, of course. Voila. Now let's run it to see if it works. We want to use the t-distribution. There's a small error here, if distribution or elif is not even better. Like that, now it should work. And as you can see, we get the parameters here. The degrees of freedom is equal to 11.84. Now as a comparison, we can also print the results for the normal distribution. As you can see, for the normal distribution the log likelihood value is minus 3251, and for the t-distribution it is minus 3236, so the student t-distribution has a higher log likelihood value, which is what you want. We can see there are slightly different parameters. The difference isn't that big. But I hope you've learned something in this episode. If you have any questions or suggestions, please comment them down below. I'll thank you for watching and see you in the next episode.